Hello, everyone. Welcome back. Today, I want to talk about quartiles and box plots. And we'll see that these are also ways of kind of describing the spread of a population, kind of give you an idea of the distribution of population. It's just a very few basic numbers and also a way to plot those numbers. So our goals, be able to calculate the quartiles of a data set, be able to create a box plot of a data set, which, as we'll see, the box plot is basically a plot of the quartiles. And then also want to make sure you can use these quartiles and box plots to make comparisons between other populations. So let's take a look. So quartiles, it says, are measures of the location of data values. And we have three of those because we're going to divide a number up into 4 parts. And so to do that, you need essentially three dividing lines, 3 numbers. Now this is like the median. In fact, the median is one of these quartiles in the sense that the individual values are not really important, is where they are in order when they're placed in order, where they are in order with the other data values. Okay, so let's draw a picture over here. And so these also relate to percentiles, and that Q2 is our median. That's called P50 or 50th percentile. Q1 is P25, the 25th percentile, and Q3 is P75, the 75th percentile. So let's come over here, and I need to make sure I have plenty of space. Let's take a look, kind of visually explain what quartiles are before we get to this example. Okay, so let's draw a picture. There's a little space here. So let's say this is our data set. And let's essentially imagine as this rectangle. And this rectangle, so here is right here, on the left side of the rectangle, this is our minimum value. Our minimum value. So our lowest value, once again, order from left to right, in order from least to greatest. This edge here represents our minimum value. Then, as you might expect, and over here, this side of the rectangle represents the maximum value. Okay. Now, as you learn, the median, you're going to call Q2, is right in the middle. And so that is what's called the second quartile, or Q number 2. So this divides it in half. So remember, this is your lower half of your data. This is the upper half of your data. Now, we're going to divide this into each half into 2 parts. So this first one is Q1. And then right here, this is Q3. Okay, so each one we're dividing each one of those halves, which divided by the median, into half again. So what we have is this is 25% of your data, the lowest 25%. This is the next 25% of your data. And then this is also 25%, and this is also 25%. So those are why they're called quartiles. So they divide your data in terms of just the numbers of data, the ranks of data, where they are, into 4 equal parts. Okay, so Q2 is your median. Then Q1 is the median of the lower 50%, and Q3 is the median of the upper 50%. Okay, these are the quartiles. And this is also what's called the 5-number summary. Which I notice in the next line. This set of data makes what's called the 5-number summary. So go and take a look at this. It says you can do this for a set of data. The 5-number summary consists of these 5 values. The minimum, first quartile, Q1, which divides the median of the lower half of your data. Second quartile, Q2, which is the median, right at the middle point of your data. Third quartile, Q3, which is the median of the upper half of your data, then finally your maximum value. And this is what's called the 5-number summary. And this data can actually be fairly useful and kind of even though it's just only 5 numbers, can often be very helpful in understanding taking a look and understanding data sets. Okay, just kind of understanding the distribution, the shape of it. So now let's actually take a look down below. We're doing an example. We're actually want to find this 5-number summary. Let's do that below with this set of data. Okay, so here we have these numbers. Okay, now they're already in order from left to right, or from least to greatest, which helps. Let's take a look. So how many are there? So 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, 8, 9, 10. And I believe they're going to be, yes, there are 20 values. Okay, so let's find these. So let's go ahead and first off, let's find Q2. That's our median. Okay, in this case, we have for n, our number of data values is 20, as we just said. So to find the median, that's going to be right here. You have to average these two. Okay, and so because it's an even number, that's going to be 68 plus 70 divided by 2, which is just 69. So this is Q2. This is also equal to P50, our 50th percentile. Okay, although we don't use percentiles for this, it's still useful to know that. Now, let's find Q1 or Q3, it doesn't matter. Let's go to Q1 first. It's the lower half of our data. So right here, so count up 5. So it's going to be right here between these two, the first 5 and the second 5. This is going to be us our Q1. So base is going to be 64 because we have an even number once again in our lower half. So it's going to be 64 plus 65 divided by 2, which is just going to be 64.5. Okay, 64.5 is our Q1. That's also our P25, our 25th percentile. Then let's find Q3. Okay, and we start with the upper half of our data. Once again, we have 10 data sets in the upper half, so we have to average the middle two. So it's going to be between 75 and 79. And that should be, I believe, 77. We can always double check that. Yeah, 77. So we have to average these two values, okay, for Q3. And it's going to be 75 plus 79, which is going to be 77. So that is our Q3, but it's also our 75th percentile. And of course, we can also see from our data, our minimum value is 31, and our maximum value is 94. Okay. Now, those three numbers by themselves, all useful, don't really help as much as a picture. A lot of times, if you can see a picture, it's often easier to visualize things that way. So, next thing I want to talk about are box plots. Box plots is essentially just a plot of a box plot is a plot of the 5-number summary. And we'll show how to do that with this 5-number summary. This is a plot of this 5-number summary. Okay, so let's read this over here about box plots. This is a box plot, sometimes called a box and whisker plot. You'll see it called that. You'll see why. It's a graph of the data set consists of a line. So once again, plot the 5-number summary consists of a line extending from the minimum to the maximum value, and then a box with lines drawn at the first quartile, the median, the third quartile. Okay, and that's reading that may not make a lot of sense, but it makes sense when we actually do it. Okay, and the procedure for constructing a box plot is as follows. So find the 5-number summary. You've already done that. Then basically draw a line segment from the minimum value to the maximum value, and then draw a box, a rectangle extending from Q1 to Q3. Okay, then draw a line to the box to the value Q2. So saying all that, let's actually do that. So let's go down here, and you can do them either vertically or horizontally. Okay, some people do both. I think I'll do this one horizontally. So let's think about our data. It's just putting kind of a horizontal scale. So our data go from essentially 30 up to 100, more or less, a little bit overlap. So let's do 30 40, 50, 60, 70, 80, 90, and 100. Okay. Now, our minimum values once again is 31. So we're going to put a little line like this. Okay. And I'm just going to make a straight line all the way to our maximum value, which is 94. So that's right about here. Okay. Now, next part is, so this is from minimum to our maximum values. It essentially shows you the range of your data. Now, let's think about the box part then. So we're going to create a box that goes from our minimum, our Q1, which is 64.5, to our Q3 of 77. So 64.5 is right about here. And of course, 77 is right about there, let's say. Okay. Now, the last thing I'm going to do then is we draw a line where the median is. The median, or Q2, was 69. And so 69 is right about here. Okay. What this does, this is our box plot. What this does is just kind of a graphical representation, a very simplified but a useful one, graphical representation then of this data set. Okay. So you see the range. We also got to get a feel for how symmetric or asymmetric it is. For example, this doesn't look like a bell-shaped distribution because it's kind of skewed to this side, kind of tilted to this side, or maybe skewed to this side rather. Okay. This kind of gives a visual idea of these 5-number summary of this data. It can also be really useful for plotting different, for comparing different distributions to each other. Okay. Now, before we leave this, I want to show how we can actually do the same thing on Microsoft Excel. So I've got a window open for that. Let's go to Microsoft Excel. Now, this is a data set I made up. This is not the same data set. This is a data set I made up. Let's imagine these might be exam scores. Okay, so I have 20 of them. And also here I have the mean and median. So our mean is 67.5, or about 67.7. Our mean is about 67. So very close together. And the range of the data goes from, right now, goes from 50 to 83. Okay. Now we can create a box plot with this. I'll show you how on Excel. So first off, click on the first data value and drop down to highlight all of it. Come over to insert, and then it looks at our different charts. There are several charts we can do. Click on the one that looks like a histogram. It says insert statistic chart. That's what we want. So click on that. Go in box and whisker plot. And there is a box and whisker plot of this data. Okay. So you can see this data here, well, not perfectly symmetric, looks a lot more symmetric. This little star right in the middle, if you can see that, that little star is our mean, which isn't part of our 5-number summary, but it's also useful to see where it is. Okay. So this is our maximum value, our minimum value. Once again, the line through the middle is our Q2. That's our median, which we said the median down here we said was about 67. Okay. Then the bottom of the box is our Q1. The top is Q3. So once again, what we have is from this, and this also was called a box and whisker plot. These look kind of like whiskers. So from the minimum to the Q1, you have 25% of your data. From Q1 to the median, you have another 25%. From the median Q2 to Q3, you have another 25%. And then last, you have 25% from the Q3 to the maximum value. Now, let's imagine what would happen if this data was skewed somewhat. This is looking fairly symmetric. So what the nice thing about Excel, I can replace a value. So let's actually do that, and so we'll update everything. So let's imagine these were exam scores. Maybe someone had a bad day, let's say made a 20. So if we put a 20 in here for our minimum, think about what's going to happen. Okay. Then our whisker goes, our minimum is going to drop way down here. We'll see the effect of that. So let's put in 20 instead of 50. It will update everything. Okay. Now you see what it did. In this case, it updated. It's actually, it didn't change our mean or median all that much, but it actually put a dot right there. So that's actually, it's actually considered that to be an outlier. So what it's doing is, and once again, this is one of the disadvantages of systems like this, that sometimes they may kind of make the program to make their own choices in a sense. So the reason there's a dot here, consider that to be an outlier. Okay. So basically it's taking the 53 is being actually the minimum and it continues to be an outlier. So let's change this again. Let's make this say 35. So something that is extreme. Hit enter. Okay. So there I made this 35. This time it's not considering that to be an outlier. It depends on how Excel is programmed. See, it still doesn't change our mean or median too much. You see our whisker is longer here, representing the fact that now our minimum value is right here. Okay. So I said these can be really useful in actually then comparing different data sets, because a lot of times it's easier than trying to compare even something like a z-score or something like that. Z-scores are good for individual values. These are pretty good actually for comparing different data sets together. So let's go back to the main page. So once again, what we learned is that quartiles are three numbers used to divide our data into four equal parts, depending on terms of the number of data. These are your quartiles. It gives us what the minimum maximum gives us what's called a 5-number summary. Then a box plot is just a plot of the 5-number summary. And so it's often a really quick and easy way then to plot your data and kind of get a feel for your range and your distribution of your data, and then be able to compare that data set to another data set. Thank you. Have a good day.